Good
Okay.
morning and welcome to today's West Midlands CIBSE Stainless Steel FireTube Technology by AIC. I'm pleased to say that I'm joined by Stephen and Stephen from AIC, whose objective of today and the presentation is understanding why we use stainless steel in our products, the benefits of FireTube technology has over traditional water tube heat exchangers, and the benefits to the specification and installation and ultimately the end user. I'm joined today by Stephen and Stephen from AIC, and I'll hand you over to Stephen, who will do today's presentation. Thank you for joining us, Stephen, and thank you for today.
Okay. Thanks for that, Josh. I'll take you through this presentation, and any questions, if you just let us know as we go along, and we'll answer them. Okay. Thanks everyone. So I'll just carry on with the presentation. Okay, give me a second. Okay, so the agenda and the contents for it is just to give you a company overview on AIC, our manufacturing process, why we use stainless steel, why AIC FireTube technology that we use in the products, and what the product range are that has this technology within it. Okay. So just to comply with CIBSE, we've got 4 objectives: understanding why we use stainless steel in our products, the benefits of FireTube technology over traditional water tube, and the benefits to the installations and specification, and ultimately, as we all try to do, is bring the end user benefits. Okay, so hopefully I'll explain all this as we go along and summarise these objectives at the end. Okay, so just a brief outline of the company. We're just over 20 years old. We're based in Poland, and that's where we have 3 factories in Poland. One we make the tubes for the FireTube heat exchanger. One we make the full heat exchanger, and one is assembly of the full finished good boilers. Okay, we've got locations throughout Europe, North America and Asia. Currently we've got about 1,000 employees. As you can see there, the split is a third in engineering and management and 2/3 in the manufacturing and logistics. So currently we've got about 1,000. That fluctuates, 100, 150 either side, depending on time of year. And just our financial year just ended in March, and we turned over just short of 120 million euro. Okay. Okay, so this is just a brief timeline of the company. I won't go through everyone, but I'll just touch on the most important years for us. 2004 was a breakthrough year where we developed the FireTube heat exchanger, which we're going to speak about today. And 2011, we were invited to go to North America because they'd seen our technology. We went over with the FireTube heat exchanger. 7 leading manufacturers in North America decided they liked it. They wanted to introduce it into their products, and they did, and they still do. Right now, that number's maybe up at 9 or 10. So some leading manufacturers over in North America. Okay. And 2017, we decided as a business that we make the heart of the boiler, so we may as well develop a finished good, a complete boiler. So we built an assembly plant. We opened offices in China, and then in 2018 we set about opening up our European division. So we opened up our headquarters in Weert in the Netherlands. And at the start of 2019, we started opening up the subsidiaries, of which the UK and Ireland were the first one. Okay. And from that time, from the beginning of 2019, we started opening other subsidiaries, and you can see we've got quite a good coverage of Europe now. Okay, and we did that in the height of the pandemic. Okay. Ultimately, the AIC is an engineering business. We design heat exchangers, we design boilers. So ultimately, we're an engineering business. Okay, so part of our process when we're making and designing a heat exchanger is we use CFD technology through ANSYS software, computer fluid dynamics. So we design and simulate a heat exchanger using this software so that we can see the efficiency of the heat exchanger. We can see the flow of the flue gases, the flow of the liquid within the heat exchanger, and we can see where there's a potential problem, and we can change that, and we can see how efficient we can get the heat exchanger. Okay, by creating the turbulence of the flue gases going through the heat exchanger and also the liquid to make sure we're maximising the surface area and the heat transfer, okay, to make it the most efficient heat exchanger that we can. Okay, if you look here, you can see this is a graphic from it where you can see the flue gases going down through the heat exchanger there, and you can see that this heat exchanger tube is formed but with a flat sheet of stainless. It's then formed into a tube, and then it's pressed. It's pressed and maximising the efficiency of the heat exchanger. Okay. Okay, we have two thermal labs, one in our factory in Poland and one in our R&D centre in Weert in the Netherlands. And I won't read that word for word, but you can see we can test everything from 10 kilowatts to 2 megawatts with all the various tests, so we can self-certify our products. Okay, as I say, we are an engineering business. We design and we engineer heat exchangers. Boilers is our core business, but we also work with other industries, the food industry, swimming pool industry, even data centres. Wherever there's a need to exchange heat from one area to another, then we can design a heat exchanger to do that. And we've got a dedicated team of engineers that do just that. Okay, so that's a little bit about the company and a little bit about the history. I'll take you through the manufacturing process. Okay, so the machine that we use, we've got a couple of little movies in the next couple of slides where it shows you how we manufacture. So we manufacture the heat exchanger using CNC machining, tube fabrication, advanced welding and automation. The reason that we talk about this and show you this is there's very few manufacturers in our industry that make their own heat exchangers. From stainless steel heat exchangers, I think there's only ourselves and one other. Everyone else buys it in from heat exchanger manufacturers, but we manufacture it ourselves. Two reasons for that. One, we have total control over the quality of the component that we put into the boiler. And two, which is probably more important these days, is the supply chain. So we've got total control over the quality and the supply chain. Okay, so take you on to the next slide, which shows you the CNC machine. There's a little 30-second movie after this, and it's got music. So if you want to put your volume down, please do that. Okay, so you'll see here we're cutting out the base of the heat exchanger. Okay, so you'll see this in the little movie we've got. Okay. So now we move on to tube fabrication. As you can see again, the tube comes to us as a flat sheet of stainless steel, and we then form the tube, and we then create the surface area. As you saw from the last one, we press that, or we put dimples in it just to create turbulence for the flue gases to go through. Okay, so I shall show you the next little movie here. Okay, so that's showing you how we make the tube. As you can see there, it's slightly out of date. We do over 3,000 kilometres of tube a year in the factory, and I think we use somewhere in the region of 15 to 18 tons of stainless each week to create the heat exchanger. Okay, so then we go into advanced welding. You can see here this is a heat exchanger from the tube that you saw earlier on. So this is for the larger units. Again, you'll see the whole process of advanced welding. Okay, and the last little movie here shows you the automation of which was a big investment, 7 8 years ago within the business, to make the whole process go a little bit more smoothly. You'll see from this as well that as we go through the final process of the manufacture, it goes through a test where you'll see lasers going onto the heat exchanger to make sure that all the connections and tappings are in the exact same position for every heat exchanger. If you don't, if they're not in the right position, then the production line halts and it has to be taken off and started again. Okay, so. Okay, so that gives you a flavour of the manufacturing process. All those little movies were filmed within our manufacturing plants in Poland. Okay, so now I'll go on to speak about why we use stainless steel in our heat exchanger. Okay, so what we've done is we've broken it into 5 segments: corrosion resistant, mechanically superior, lower maintenance, consistent water flow, and hygienic. Okay. So corrosive resistant, I think we all know that the qualities of stainless steel, but you know, when we look at the manufacturing process and we look at the natural film, oxide film that forms on the stainless steel, this is what gives it its corrosive resistance. And once that's broken and comes back into contact with oxygen through water or air, then that will reform itself. But part of the whole manufacturing process, we pacify that and to accelerate that process, so that everything that comes out of our factory is all has this natural film on the heat exchanger. Okay, currently I think that at last count there was somewhere in the region of 60 recognised grades of stainless steel. Okay. The other advantage, mechanically superior. So we look at this, the strength of stainless steel. We look at it from a yield strength and from a tensile strength. So if you look at it from a yield strength until pressure's put on it until it permanently deforms, stainless steel's 550 megapascals, or an old money 5,500 bar pressure before it deforms permanently. And on the tensile strength until it breaks, it's up to 900 megapascals. So if you look at that against probably our closest rival in the heat exchanger world is aluminium. So in the yield strength, it's over 20% stronger, and in tensile strength, it's over 40% stronger. Okay, what that allows us to do, that allows us to use thinner stainless steel, which is lighter. So it allows us to make our products lighter than maybe some others. Okay. And the hardness of stainless as well it's a very hard alloy. Again, if you look on the chart here, it's measured in HB, which is 290 HB. Again, if you look at that against aluminium, which is 60, so it's 5 times harder material. And what that allows is, you know, consistent water flow. So when you've got, you know, high velocity water going through the heat exchanger, then it's much harder and can sustain that pressure going through the water, and it won't corrode or erode either for the other reasons that I said. So you have no breakage in the water flow at all. So you get consistent water flow, and with consistent water flow, then you get maximum heat transfer and no loss of efficiency through time. Lower maintenance. The experts tell us when you look at the pH chart that stainless steel is more stable than aluminium, for instance, where it's got stability in the pH chart between 4 and 9, whereas aluminium is much less than that, maybe between 5 and 7. Okay, so what that allows is lower maintenance, so we don't have to dose it as much or as frequently. So we don't need to use as many chemicals going through the boiler with this stainless steel heat exchanger. Okay. And hygienic, for all the reasons that I've already said, with the corrosive resistance nature of it. And I think testament to that is I think if you look at any commercial kitchen up and down the length and breadth of the country, they all use stainless steel surfaces, and there's a reason for that, and it's it's hygienic. Okay. Okay, so that's why we use stainless steel, and then fire tube technology. Why fire tube technology? Okay, well, let me explain it again. We've broken it into 5 sections: water and gas quality resistance, scalability, large water volume, self-cleaning, and again, lower maintenance. Okay, so if we look at a traditional water tube, stainless steel heat exchanger there, you can see from that there's very narrow waterways. So if you've got any contaminants in the water, you're going to get them building up at the base of that heat exchanger. Okay, and when they build up there, it's very difficult for them to move them. So what that does is that effectively creates a hotspot, which will affect the efficiency of the heat exchanger and ultimately will lead to premature failure. Okay, and the same when you look at the flueways in between the coils there, they're very narrow. So if you've got any build up, you've got poor gas quality, you'll have build up of gas residue there. You know, you'll get some calcification in between the fins, and the same result is that it will affect efficiency and lead to premature failure. Okay, so how does FireTube counteract that? Well, if you look at the heat exchanger here, first thing is gravity plays a big role in it. So it's a down-firing burner, it's a vertical heat exchanger. And you can see from the image on the right hand side there, there's larger waterways. So any build-up of any contaminants within the water won't really stick to the side of those tubes because it's a larger waterway. If they do, these tubes expand and contract as they heat up and cool down, so they shake off any debris, and that's out through your system. And on the flue side, there's larger flueways, so you've got down-firing burners, so you're pushing the gases through it. Also, the gases condense as they go through the tube as it gets cooler at the bottom, so it flushes out any build-up of gas residue out through the fire tubes, out through the condense dish, and straight to waste. Okay, so that greatly reduces the possibility of premature failure within the heat exchanger through poor water quality or gas quality. Okay, and this is an illustration showing you that. On the left-hand side, you see the fire tube, so you can see the larger waterways, the larger flueways, and on the right-hand side, with the water tube, you can see the contaminants building up at the bottom of the tubes and within the very small flueways. Okay. Okay, we talk about the footprint. This is given a footprint of the heat exchanger, and the way the heat exchanger is designed, the bigger the output, the more tubes that we put on it. So we put them in a circular fashion. So you can see 280 kilowatt to 840 kilowatt. So you're looking at about a third bigger footprint, but almost 300% increase in power using this type of heat exchanger. Okay. And this is just demonstrating again larger water volume on with the fire tube heat exchanger against the water tube. What that does, because you've got higher water volume, we've got more stability in the heat transfer process. So it's making the heat exchanger a bit more stable through the whole heat transfer process. Also, it helps with the pressure drop. So if you look at the pressure drop going through, you know, if I take, for instance, 120 kilowatt boiler, the pressure drop going through that is probably about 60% less than it is going through water tube. Okay, so that helps with the sizing of pumps, etc. Okay, self-cleaning. So you can see for all the reasons I said earlier, you've got the fire tubes there, so you've got the flue gases going down inside the tubes. You've got it condensing, so it's turning to liquid and washing out any gas residue. And on the water side, again, as I said, any build-up of contaminants on the side of the fire tubes, then these tubes expand, contract, and it'll shake off the debris and break it out and go through the system. Okay. So what products do we have that has this fire tube technology in? So we have the Nesta family, which is wall-mounted range. I'll go into that in a little bit more detail. Small floor stand and larger floor stand, and our flagship Coil Master range. Okay, there's a couple of slides at the end that CIBSE have allowed us to add on, just to talk a little bit more about that technology and the products that it's in. Okay, just to summarise the objectives that we set out. I won't read that word for word, but understanding why we use stainless steel in our products. Hopefully, from the slides earlier on, you can see the reasons why we use it, the strength and hardness of the stainless steel, as to longevity of the product, the benefits of FireTube heat exchanger technology over traditional water tube. Again, hopefully I've explained the benefits, and really it's about the longevity of the heat exchanger and ultimately the boiler. Okay. The benefits to the installation and specification. Well, again, longevity of the product is key. Footprint is also a big factor as plant rooms get smaller. So you can see the benefit there of having a smaller single heat exchanger boiler, and ultimately the end user benefits, which for me is the most important part. There's no loss of efficiency because there's any build-up of contaminants in the heat exchanger, which helps keep the fuel cost down, which is an important factor these days. Longevity of the product, so no premature failure. Self-cleaning heat exchanger, so reducing maintenance costs, and wider stability within the pH. Again, reducing maintenance costs because it's less preservatives have to be put into that system. Okay. Okay, so just to just briefly talk a little bit more in depth with the products that you find FireTube technology in. We have the Nesta Chrome range, which is wall mounted. We have standard ranges from 60 to 150 kilowatt. We also do a smaller range, but not on the Cascade rig. And what we tried to do, for all the reasons I spoke about stainless steel, we tried to bring the heat exchanger and the qualities of stainless steel outside the boiler. So you can see here from the whole Cascade and system here and the hydraulics, they're all manufactured from stainless steel. So again, bringing the qualities of stainless steel outside the boiler as well, and you can see that in the manifolds there and the low loss header. Okay, and if you look at internally, if you look at the heat exchanger there, there is no mechanical joints on that heat exchanger. Okay, everything is welded stainless steel in that heat exchanger there. So the weakest part is the mechanical joint, so that's not there. Okay, and then also if you look at the bottom of the heat exchanger there, the condense dish is also manufactured in stainless steel. Okay, so and it's welded stainless steel, so there's no threat of any perforation to washers going around that, so you're not going to get any products of combustion escaping into the casing of the boiler there either. Okay, so it's not going to be like the plastic where it gets brittle and hard and cracks, and again you get products of combustion escaping into the enclosure of the boiler. That element has been taken away by using this heat exchanger and condense dish. Okay, and then we have the floor standing range. So that goes from 120 to 300. They all have the same heat exchanger as the wall mounted, only it's a little bit longer. Okay. And again, you can see the full stainless steel theme running throughout and internally of that boiler. Again, no mechanical joints on the heat exchanger at all. Then we have the bigger range, going from 280 up to the ones highlighted there in orange are new products. So going from 280 up to just over 1.2 megawatt boiler, again using that same FireTube technology. Okay, and again you can see the same theme running within the internals of that boiler. Again, fully stainless steel, no mechanical joints. Okay, and then we have our flagship product, which is the Coil Master, which is a water heater that also does your heating if required. So again, goes from 35 up to 120 kilowatts. Okay, so you can see internally here we've got the same theme running throughout with the stainless steel, no mechanical joints. On the left hand side, you can see the FireTube running in the middle of the domestic hot water coil. Okay, so domestic hot water coil goes through that stainless steel coil, so it's an instantaneous water heater that also does your heating. Okay, so if you look at that unit there, if 120 kilowatt can, using the FireTube technology, can produce over 1,800 litres every hour of hot water at 60 degrees. Okay, from a very small footprint. Okay, and then we have our Texas using a different style of FireTube heat exchanger. You can see that there we've got helical design heat exchanger there, where the flue gases go through and heat up a store of hot water. But the Texas is a high volume, high performance, direct fired water heater. So again, you're getting close to 4,500 litres in the first hour at 60 degrees from again a fairly small footprint, 1 square meter footprint on that. Okay. And all that technology is used in our hybrid heat pump solution as well, but that's not part of the presentation. I just mention that at the end, but that's something that if you want to talk about, we can talk about another time. Okay, where we've introduced a heat pump, the backup boiler, and a thermal management unit to control both heat sources, which is really designed for existing buildings. Okay, where it's been designed on an 80 degree flow, and there's no willingness to change the heat emitters or the pipe work or the fabric of the building. Okay, but they do want to decarbonize. Okay, so that kind of completes the presentation. If there's any questions from anyone.
Haven't seen any questions yet, but there is another session scheduled for later on today, this evening.
Yes.
So if there's any questions or queries in the meantime that come in, then we'll share them during the next session. But yeah, really interesting. Thank you, Stephen and Stephen, for today's presentation, and interesting to see the other products and services within the range, which may very well feature on a future event. But I think for now we'll close today's session. So thank you both very much. And we look forward to the next event with yourselves. So future events are available via Eventbrite. And if anybody's got any feedback or input or comments, then we'd love to hear from you. So that's either via the feedback@cibsewm.org email address, or contact details for Stephen and Stephen will hopefully be in the description and the bio of the video on YouTube and other social media platforms. But for now, thank you very much, Stephen and Stephen, and I wish you a good day.